Negative 2 square roots of x minus 4 plus 3. Reduce square root of x. That's mom. So mom is y equals root x. Mom has 3 key points. Mom's 3 key points. 0, 0. Because the square root of 0 is 0. What's another one of them? 1, 1. And 4, 2. Mom looks like an arm. We expect our child to look like an arm. Now, before we actually graph it, can you tell me what transformations you're going to do to that child? You have to flip it over the x-axis. There's a reflection.
Move right.
Will be a move right 4. Reflections. Going to reflect on the x-axis. I heard we're going to move right 4. Shift right 4. We call that a horizontal shift. I heard you got 3. That's a vertical shift. Anything else? When it gets taller, even though it goes down, it's taller, you can stretch. Vertical stretch. What you got, Austin?
The last room, yeah.
Well, that would help, wouldn't it? Yeah, it's going to be twice as tall. There's a y value out there in front of that thing is 2. That's going to double all your y values. That's a vertical stretch. There's a way to teach this by modifying points. I just don't want to do that. So everybody should have an idea what this thing's going to do. We go to the right 4, up 3, and how's it going to open? Like that. Right? Going to go right 4, up 3, and open down. Just what's opening up. That's the new origin. That's where the child is centered at. That also is going to help you make your little table. This thing's centered right here at 4, 3. Now, yesterday I was trying to get you guys to realize that you're trying to take the square root of 0, 1, and 4. That works for some. Let me talk about mom's little table here. This might make more sense for some of y'all. Mom's table went 0, 1, and then what? 4? To get to a 1 from 0, you add 1. The next entry in this table is going to be 5. And then 8, because to get from 0 to 4, you add 4. 8. I think. Should be. So let's plug that 5 in. What's 5 minus 4? 1. Square root of 1 is? Times the negative 2. Negative 2. Add 3. 1. How do I do what? Comes from previous notation. That means we shift opposite of what it says. That's right 4. And the end is saying up 3. Could have said minus, we'd have said down 3. So the centering here is at 4, 3 because we went right 4 and left 3. That's where it came from. Plugging in the 8. We got an 8 minus 4 in that radical. That's a 4. What's the root of that 4? 2. What's the square root of, sorry, what's the negative 2 times 2? Add 3. 1. There's all you need to graph this whole thing. So to the right 5 up 1. And to the right 8. Let's get into all my little written text over here. Down 1. I had to actually graph mom on the same thing. You see the child's quite a bit bigger than mom, isn't it? Yeah, Sean. Huh?
Domain.
Domain.
Domain would be 4, bracket 4, comma, K.
Bracket 4 to infinity, I agree with that.
And range is parentheses negative infinity, 4 bracket. 4, 3.
3 with a bracket. Good, you actually said it right. You went low to high. Domain and range, they both represent, you start with a small number, proceed to the high number. A lot of kids would mess up the range on the second one. They would say 3 comma negative infinity. It's very common. That is a very bad looking graphic there. So there's a recap of yesterday. You understand how I came up with table values today?
I get the 4.
If you get the 4-3, that's where you start. I thought about mom's table. How far apart are 0 and 1? So the next entry over here has got to be 1 unit away. You see it? How far apart are 0 and 4? 4 units. So then the third entry has to be 4 units from 4. You think about mom. What it all comes back to. Think about what mom looks like. Think about how mom behaves. That's how the child's going to behave. All right, we actually graphed something like this yesterday in your class, I think. I think we graphed a cube yesterday. So here's another cube. And again, it's going to look something like mom. Whatever mom looks like, the kid looks like. Well, mom has 3 key points. What's one of mom's key points? 0, 0. That's another one of mom's key points. 1, 1. About another one of them. 2, 4, no. 2, 8, yes. 2, 4, no. That's mom's 3 key points. Is mom alive? No. Mom starts her day low and ends her day high. It's kind of following the curvatures of my arms here. That's on the board too. Mom is a snake that likes the y-axis. That's what mom looks like. Because this is a cubic function over here, the kid's going to look like mom. You need to go ahead and kick in your ideas of where the new center is or how we move along the x-axis. I see an x plus 4 in that set of parentheses. How do I shift? I shift left 4. The opposite of what's in parentheses. Right there is a left 4. What's that plus 2 tell me? Up 2.
So how do you, the mom, it can be different every time? It depends on like the equation?
No, this is a cube function. Mom's got to be a cube. If it's a square root function, mom's a square root. Not everything has the same mom, does it? Everything has the same mom, different moms. All right, so, and I show these, a lot of kids don't. Right, this is, They just view that they don't need to do that. And they never do well with it. Now, and I think about mom. Mom had two other key points. They were to her immediate left of her center and to the immediate right of her center. You see that? She was centered at 0, 0. There was a point to the immediate left and there was a point to the immediate right. Now, if you think about mom's table, her center was at 0, 0. There was an x value at -1. There was an x value at +1. They were both y values of 1. When I start thinking about the table for this child, I'm centered at -4, 2. And I need to go 1 unit left, 1 unit right. -5 is one of the x values. What's the other x value? -3. If you use other x values, you're not going to get nice numbers. If you use those two, you end up getting really nice numbers. Well, in this case, they're actually decimals, but better than some of the other numbers. All right, so I plug in a -5. I have a -1. What do I get when I cube a -1? -1 times a half is a -1/2, right? I add 2. What am I at? Positive 1.5. 3 halves, whatever you like. Doesn't matter. I plug in a -3. I have a -3 plus 4. That's 1 all day long. What's 1 cubed? 1 times the half out front plus the 2. Good. Notice the difference between these guys is the same. Both half unit away. That's the nice thing about those things. They stay the same distance away from the center. Back 5, I'll divide a unit in half. Back 3, of about 2. This thing has actually been compressed. You wouldn't realize it, but it has been compressed. Because initially, the child is only about half the height of the mom, isn't it? It's called compression. So there were a couple of transformations that went place on this one. We shifted left 4, horizontal, shift. Horizontal shift of left 4. There was a vertical shift. Up 2. And what's that last one, Sean? There's a vertical compression factor of 1/2. A couple of years ago, I put a hint on the test question from this section. I left the F out of shift. You know, for some of you guys are taking like the 70-point, 80-point version. Well, the hint told you how to take a vertical sheet. Oops. Nobody caught it either till I mentioned it the next day. I was like, yeah, I know y'all aren't reading. I know you idiots taking that 75-point version didn't read the hint. Because every one of them missed the fact that I cussed at them. And I didn't mean to. All right, these are kind of identical. What's the domain and the range of this child? What's the range? Same thing. It'll run forever, albeit very slowly to the left and to the right. And it'll drop and fall really quick as far as range goes. So they're both negative and positive. Let's see, what's up next in your notes? Should be a cube root function. The graph on these. Square root's the arm. Did we get to a cube root yesterday? Cube root is this. Now this is a new mom function. cubic root of x, another function of all cubic root functions. I got a little table there. I only focus on these three key points, but that's because I've done this for years and I know what it looks like. But the reality is there's 5 points that matter to get the true graph. So we take cubic roots of these x values. What's the cubic root of -8? -2. What's the cubic root of a -1? -1, cubic root of 0, cubic root of 1, 1, cubic root of 8, 2. You can do it with the first 3 if you know the shape, but if you don't, you got to use 5. You can go back 8, fall 2, back 1, fall 1, 0, 0, right 1, up 1. Right 8, up 2. Again, that's what it looks like. Does it look a lot like x cubed? To some degree? Yeah, it's x cubed rotating 90 degrees. And there's a reason it looks like x cubed. Curvature is the same. What's the domain and range? This runs forever left, it runs forever right. What's its range? Because it falls forever, doesn't it? It rises forever. It looks like it flattens out, but it doesn't. It just grows slower and slower and slower and slower. Like the next x value after this that I would use would be 27. What would the y value be? 3. After that, the next x value would be 64. Y value 4. After that, 125. Y value 5. It is getting bigger. It's just slower and slower and slower and slower. The domain range on both these things are negative and positive to me. It's kind of kick back to Tuesday. The cube root is the inverse of what function? X cubed. The exact opposite action. The inverses are the exact opposite thing. Which is kind of why the graphs are similar. They're similar to a curvature. And there's a new mom for you. Who's your favorite mom so far? Absolute value, x squared, square root. Like x cubed. You know why? She's got some curves right there and she's tall and skinny. You like x squared? Is it because it looks like a boob? Is that why?
No, I'm just more familiar with the x squared.
All right, graph y equals negative x minus 3 to the 1/3 plus 4 by finding a center and 2 other points. This probably isn't obvious to some of y'all. What root is that? Cube root.
All right, that's a cubic root for you. That is a cubic root. We talk about power over root when we talk about this exponential form. This is equivalent to y equals negative cubic roots of x minus 3 plus 4 on the outside. And I'll even encapsulate that x minus 3 instead of parentheses for you to help you out. I know some kids don't get that. I know a lot of kids don't get that. I rewrite radicals and the exponents and vice versa. So we're going to transform mom. Before we start, tell me what transformations are. Right 3, up 4, those are the easy ones. Opposite, trust. Anything else? Another fairly obvious one. Reflection is negative up front. It's out front. It's not right by x. It's out front. What are you going to reflect on? Reflect on the x-axis. I'm going to go ahead and draw mom real quick. Always think about the mom. I only focus on mom's 3 key points. I don't focus on all 5. Oh, this is x cubed. It's cube root x. Sorry. Redraw mom. I drew a different mom. The reason I redrew mom is because mom has a center. Then you have an x value right before the center and an x value right after the center. It's the same exact thing I'm going to do when I grade the table with my child. Just focus on the attributes that mom has. So mom, according to Sam, got shifted right 3, and I think he also set up 4. You guys agree with Sam? You understand that? We've been doing that for a long time. Ever since absolute value, we've been doing opposite of whatever's in there. I know we have. Right 3 up 4. And that is what I'm referring to as a center here. That is this thing's center. So I make a small table with the entry 3, 4 in the center. And what's to the right of 3? 4, actually said that backwards, isn't it? What's to the left of 3? 2. You have your x values, kids. Well, the reason we use these is because if you go immediately left and immediately right, you're trying to take the cube root of 1 or negative. Easy things to work with. No reason to use them. So I plug a 2 in, I'd have 2 minus 3, which is negative 1. And what is a cubic root of negative 1? Negative 1. And there's a negative out front. Makes a positive 1. You add 4, 5. If I take cubic root of, sorry, if I plug a 4 in, I have a 1. Cubic root of 1 is a 1. There's a negative out front, so now it's negative 1. I add 4, 3. And you'll start seeing your reflections too. So the right 2 up 5. Zero's that point, center's there. And the right 4 down 1. You should see your reflection. Because it did reflect on your new x-axis. Because you shifted that x-axis up. It did reflect on it. And that's why it starts high and ends low. Anybody got questions on it? What most kids struggle with again is tables.
What's the domain and range of this thing? Same on both. Just like mom. Your x cubes, your cube roots, they're all the same. Yeah, it's a little more different. It is. And if you just look at it, you don't actually see the true shifting. It's kind of interesting how these work. It is. But go ahead and tell me what you think happens. You do, to see the actual true reflection, the true transformations, you have to distribute. So let's rewrite that as a radical while we're at it.
Negative x minus 2. Outside of that thing, what? Minus 4. Now what's funny about this is we're actually going to draw over here. If we follow, sorry, we're actually going to draw over here. If we look at this, we're thinking we're drawing right here. They're kind of funny on that. They really are. You know, when you look at this thing, you're supposed to say shift right 2. That is the actual transformation that happens. I talked about that yesterday. It gets shifted right, then it gets reflected and ends up in the exact opposite spot. So you shift right 2, you drop 4. So kind of think that's your center. Shouldn't be. But who knows? Maybe it is on this one. We did a square root function yesterday, didn't we? They are a little bit different. Well, let's see what happens if we try to plug in like a -1. Sorry, a +1. It might actually work out on this one. If you plug in a +1 right here, what are you going to be attempting to take the cubic root of? Plug in a +1, you can take the cubic root of -3. See, it doesn't work, does it? You kind of have to go back to this. Reality is because of that reflection on the x-axis, this is forcing. Your center is actually over here. It's kind of like we'll almost call it a false shift. It is a transformation happening. It is. I talked about it yesterday, guys. Reflected on the y-axis. I may end up over here.
4, that it flipped to 4. I reflected.
I don't even know what you said.
Instead of 2, 4, it's at negative. Or instead of 2, -4,
Two,
it's at
-4.
-2, -4.
This is the actual true center. And I can get how that can be a little confusing. So anyways, I'm actually going to center this thing around -2, -4. The immediate left of -2 is -3, and to the immediate right of -2 is -1. And those numbers will work. Because if I plug in a -3, I'll have -3, which makes +3. -2 is 1. What's the cubic root of 1? 1. Times 2 up front makes 2. Take away 4 makes -2. If I plug in that -1, I'll have -1, which is +1, and -2, which is -1. And the cubic root of -1 is -1. Times the 2 makes -2, subtract 4, and then -6. So, back 3, fall 2. Back 1, fall 6. And remember what mom looks like. Mom's not something that starts like this and goes like that. Mom's like this, right? Now our points are telling us that we've got to come in the pi, which is kind of interesting. I'm surprised our points are telling us that. But they sure are, aren't they? Oh, because we reflect on the x. Yeah, we reflect on the y-axis. That's the only fact that we reflected on the y-axis. Well, it's coming in a pi and well. The other reflection here was the reflection on the y-axis. And that, kids, is that. We've got 17 minutes to get your homework.
Why would you reflect that like that? Because we have a different order. That's what I was trying.
Where the negative's located,
On the x. That's why. So if the x is negative, that's
we
what
reflect on the y-axis every time. It's not phone time. It is not phone time. Why?
So I say the order.
If you want to, it's better be on Google Classroom when I go by. Every time a kid tells me they're on Google Classroom, 2 months later they're on Snapchat. Yeah. You need to be doing Khan Academy. All of y'all do. Not all of y'all, most of y'all do.
I would choose Bethany.
I reckon.